All right, so there are some steps you're going to use when solving rational equations and on the worksheet. And so when you go to the worksheet, you're going to see that red notation. So that red notation, the way that is done there is this way here. So the first thing you're going to do is you're going to multiply both sides of the equation by the least common denominator. Then you're going to remove any grouping symbols, in other words, distributing, things like that. And you're going to check your solution. You're going to check your proposed solution. Sometimes they call this the proposed solution. And you're going to see what I mean by that proposed solution. You always have to check that proposed solution in the original problem, and you're going to see why when we go through this process. All right, so let's look at this first example. So the directions will say solve each of the following rational equations. So solve each equation. Solve each equation. Now, these are going to be rational equations. Let me remind you about why this equation, number one, is a rational equation. So 4x plus 7 divided by 3 equals 2x plus, I think that's going to be a 7. I think that's a 7. So yes, 7 divided by 2. Okay. Now, so this is a rational equation. So a rational equation is where you have in your equation you have something that looks like a fraction. See, that's a fraction, right? It just so happens that in this case my denominators are numbers. But for the most part, in this course and also in college algebra, when you solve rational equations, your denominators would be mostly variables. So you can see variables in the denominator. But the first one's an easy one. The first one's an easy one. Your denominator is 3 and 2. So remember, when solving a rational equation, this is a rational equation because you have a rational expression and a rational expression. So a rational equation is where you have an equation with at least one rational expression. So it's something that looks like a fraction. You have a numerator, denominator, numerator, denominator. First step you got to do though is you got to find that LCD. Then you'll multiply both sides by the LCD. So if you look at your denominators, that's a 3, that's a 2. The least common denominator is a 6. So now what you're going to do is this. You're going to multiply both sides by 6. What I do to the left side, I do to the right side. Just as we talked about before, the whole point, the reason you want to multiply by the LCD is to get these denominators to be a 1. Just like we talked about previously when we looked at simplifying complex fractions. Remember, when we did this, the whole point of multiplying by the LCD is to get these right here to be 1s. The same thing with solving rational equations. So when you solve rational equations, the whole point for multiplying both sides by the least common denominator is to get this to be a 1. All right. Now, one thing I got to tell you as we go through the process, see that's only one fraction here on the left, and on the right hand side there's only one fraction. So I don't need to put this in parentheses because that's just 1, 1. So here's what I'm going to do. I'm going to write this as 6 times 4x plus 7 divided by 3 equals 6 times 2x plus 7 divided by 2. So this fraction times 6, this right-hand side times 6. So what I do to the left, I do to the right. Now, the next step is to remove any grouping symbol or reduce. So I can reduce here. 3 into 3 is 1. Remember that you wanted that 1, right? The whole purpose of multiplying by the LCD is to get this denominator to be a 1. 3 into 3 is 1. 3 into 6 is 2. 2 into 2 is 1. 2 into 6 is 3. Okay, now you got to be careful. So this is 2 times this numerator, and this numerator is a binomial. So you really should put the numerator in parentheses because now you're going to distribute. So 4x has to be multiplied by 2 and 7 has to be multiplied by 2. Same thing here. So now we get this. We get 2 times 4x is 8x. 2 times 7 is 14. Equal 3 times 2x is 6x. 3 times 7 is 21. Okay? And now notice I went from an equation from an equation that had fractions to a linear equation with no fractions. And so all you're going to do now is you're going to bring all the variables to one side, constant to the other. So you can subtract 6x from both sides. 8x minus 6x is 2x plus 14 equal. And then 6x minus 6x is 0. 0 plus 21 is 21. Then you can subtract 14 from both sides. And so I get 2x, this is 0 here, equals 21 minus 14 is 7. Divide both sides by 2. I get my solution to be 7/2. All right. Now, if I did all this work correct, then that's a solution. And so if I wanted to check it, I'd have to go back to the original problem. Now, let me say this, and it's going to be important as you work through the lessons this week on rational equations. If you have any variables in the denominator, which I don't here, but if you have any variables in the denominator, this right here will be called a proposed solution. And then you have to go back and verify that it is actually a solution. And the reason I'm not saying this is a proposed solution is because I don't have any variables here in the denominator. So I know I did all this work correct, so that's going to be the answer. But let's go ahead and check it. I want to show you how to check this. So let's check this. So I always go back to the original. So in the original, I have 4x plus 7 divided by 3 equals 2x plus 7 divided by 2. Wherever I see the variable x, I'm going to substitute 7/2. Okay, now watch how simple this is going to be now. So I see an x here and I see an x here. So I'm going to substitute the 7/2. So I get 4 times 7/2 plus 7. 4 times 7/2 plus 7 divided by 3. And I want to see if the left-hand side is going to equal the right-hand side. So that's 2 times 7/2 plus 7. All that's being divided by 2. Once you remind about this, see this 2 divides out into this 4. So 2 to 2 is 1, 2 to 4 is 2. These two divide out. And so now look what happens. 2 times 7 is 14. I get 14 plus 7 divided by 3. 14 plus 7 divided by 3. And I want to see if that's going to equal 1 times 7 is 7. 7 plus 7 divided by 2. Well, 14 plus 7 is 21, so I get 21/3. And I want to see if that's going to equal 7 plus 7 is 14 divided by 2, right? Well, 21 divided by 3 is 7. 14 divided by 2 is 7, and they are equal. So it means that what I've done here is correct. So that's a solution. All right. So, but remember, the whole point to begin with is that you got to first of all find the least common denominator, and then multiply both sides by the least common denominator, and then go from there and get your solution. Now, this right here was an easy one because the denominators did not have any variables in it. Now let's look at number 2. The same thing's going to happen with number 2. Number 2, we're not going to have any variables in it. So I just want to show you how easy it is when there are no variables in the denominator. So here's number 2. You have 9x divided by 8 plus 1/4 equals 8x minus 3 divided by 8. So notice this is a rational equation. That's a rational equation. Rational equation. So it's a rational equation because you have at least one fraction. Numerator, denominator, numerator, denominator, numerator, denominator. It just so happens that your denominators don't have any variables in it. So that makes this an easy rational equation to solve. So to solve this rational equation, you're going to find the least common denominator. So the smallest number that 8, 4, and 8 go into is 8. So that's your least common denominator. Now, remember when we did number 1, I had one fraction, and all I did at the beginning, if you go back, you'll notice that I said this times 6, this times 6. The problem here is this. On the left side, you have 2 fractions. On the right side, you have 1. So on this side, I'm going to go ahead and rewrite this over just to show you. So remember the whole, once you find the least common denominator, the next step is to multiply both sides by the least common denominator. Okay, both sides, the left side, the right side. The left side, though, has 2 fractions, so you got to put that in parentheses. You got to say times 8. The right side is just one fraction, so you don't need parentheses there. Just say times 8. Okay? Then you're going to distribute. So now you're going to say 8 times 9x divided by 8. Now remember, I want to remind you this. So remember, the whole point of multiplying both sides of a rational equation by the least common denominator is to get these denominators to be 1s. And notice 8 right here now becomes 1. 8 divided by 8 is 1. 8 divided by 8 is 1. That's the whole reason why you multiply by the LCD. Distribute here, you get plus 8 times 1 over 4. Reduce 1. That's what you wanted, right? And then 2. Equal. And then I'm going to go ahead and reduce here. So 8's divide out, and you just get 8x minus 3 times 1 is 8x minus 3. So that is just this. 1 times 9x is 9x, plus 2 times 1 is 2, equal 8x minus 3. So notice I went from an equation with fractions to an equation without fractions. I went from an equation with fractions to an equation without fractions. And this is an easy linear equation that you dealt with in previous courses. So let's go ahead and subtract 8x from both sides, bringing all the variables to one side. 9x minus 8x is x, plus 2 equal, this is 0, and you're left with negative 3. Subtracting 2 from both sides and combining like terms, I get x to be negative 3, and a negative 2 is a negative 5. So that's so the solution, if I did all this work correct, that's actually a solution. All right, so let's check it. So let's check this. So let's go back to the original equation. Always go back to the original. So here's the original. 9x divided by 8 plus 1/4 equal 8x minus 3 divided by 8. So wherever you see the variable x, you're going to substitute negative 5. So I get 9 times negative 5 divided by 8. 9 times negative 5 divided by 8 plus 1/4. And I want to see if that's going to equal this side. So this side I get 8 times negative 5. 8 times negative 5 minus 3 divided by 8. Well, 9 times negative 5 is a negative 45 divided by 8 plus 1/4. And I want to see if that's going to equal 8 times negative 5 is a negative 40 minus 3 divided by 8. Now you see this right here? That's negative 43, right? So this is negative 43 divided by 8. And over here, the least common denominator is 8. So I want you to remember this. So the LCD is 8. So this becomes negative 45 divided by 8 plus, and then 1/4 is 4 divided by 8. 4 divided by 8 is 1/4. A negative 45 plus 4 is a negative 41 divided by 8. And the, oops, I did something wrong. Oh, I'm sorry, that's a 2, excuse me. 2. So 2/8 is 1/4. So negative 45 plus 2 is a negative 43. And notice negative 43 is the left, negative 43 over 8 is the right, so those are correct. All right, so that's your solution here. But that's how you check it. All right, now let's do one with a variable. So let's do one with a variable. So this is going to be number 3. Number 3. So in number 3, we have this rational equation in number 3. So let's see. Let me go ahead and find it. So this is going to be number 3. So we have, all right, so let's do this one. So it'll be 1/3 minus 2 divided by 25x equal 8 divided by 25 minus 1 divided by 15x. Okay? All right, now, so this, even though this has variables in the denominator, this is still an easy kind because these are all monomial factors. Those are all monomial factors. Now, one thing I need to remind you, or I need to tell you now, is this. Whenever you have variables in the denominator, and that's there are 2 fractions with variables in the denominator, you have to find the restrictions. So these are going to be called the restrictions. So that's one of the things that's going to be talked about when you review those lessons. So the restrictions. So the question is this. Remember, you can never divide by 0. So dividing by 0 dividing by 0 is undefined. So for example, 4 divided by 0 is undefined. So the denominator can never be 0. So what you got to now ask yourself is this: since I do have a fraction here with a variable in the denominator, you got to ask yourself, where is 25x? Where is 25x equal to 0? Well, 25x equals 0 when x is 0, right? Because when x is 0, 25 times 0 is 0. And the same thing here. Where is 15x equal to 0? Well, 15x equals 0 when x is equal to 0, because 15 times 0 is 0. So your restriction is that x cannot be 0. X cannot equal 0. Because if x is 0, 25 times 0 is 0, so that's 2 divided by 0, which is undefined. 15 times 0 is 0, 1 divided by 0 is undefined. So the first thing you have to do whenever you have a rational equation and there are variables in the denominator, you got to find that restriction. Okay, now here's the next thing. So these are monomial factors. That's the easy kind. So it's easy to find the least common denominator now. The smallest number that 3, or the smallest expression that 3, 25x, 25, and 15x go into is 75x. 3 goes into 75, 25 goes into 75, 25 goes into 75, and 15 goes into 75. Okay? So now we're going to multiply both sides by the LCD. Notice two fractions. So I'm going to go ahead and rewrite this over. And we'll put that in parentheses, both sides, because both sides is two fractions, 2 or more fractions. So times 75x times 75x. Now remember, the whole point of multiplying by the LCD is to get these denominators to be 1s. That's the whole point. So now if you distribute, they will be factors of 1s in the denominator. So write out this stuff if you need to. So you're going to say 75x times 1/3 minus 75x times 2 divided by 25x equals 75x times 8 divided by 25, and then 75x minus 75x times 1 divided by 15x. Now let's reduce. 3 into 3 is 1. 3 into 75, let's see, I don't have my calculator with me. 3 into 75, let's see, that's going to be 2, 25, right? So that'll be 25 here. Well, I should have known that. 25 times 3 is 75. So 25 times x times 1 is 25x. Minus 25 into 25 is 1. 25 into 75 is 3, right? The x's divide out. So remember, you want 1s there. So now I get 3 times 1 times 2 is 6. Equal. 25 into 25 is 1. 25 into 75 is 3. This becomes 3 times x times 8 is 24x. Minus, and then let's see, that's going to be 15 to 15 is 1. 15 to 75 is 5. Okay? And the x's divide out. And so this becomes 5 times 1, which is 5. So now notice I went from a rational equation that had variables in the denominator to a linear equation. So now I'm going to bring all the variables to one side. 25x minus 24x is x. I get x minus 6 equal. Let's combine like terms at 0. You're left with negative 5. Adding 6 to both sides, I get x to be negative 5 plus 6 is 1. Now, this is going to be my proposed solution this time. And the reason why is it's now called a proposed solution. For right now, we call it a proposed solution is because of this. Your original equation had variables in the denominator. So you went from a rational equation with variables in the denominator to a linear equation right here, to a linear equation where you did not have variables in the denominator. So when you solve this, these are two different equations. Rational equation with variables, so that's why you have to look for restriction. And then a linear equation. So when you solve this linear equation, one is a solution to the linear one, but it may or may not be a solution to the rational equation where you have variables in the denominator. All you have to do is check your restriction. Is this proposed solution a restriction? The answer is no. This is x equal 1. This is 0. So your proposed solution is actually a solution. So x equal 1 is a solution. Okay? All right. Let's look at one more. I can have time to do one more. So let's do one more because I actually want to do this one. So this is going to be number 4. So this is number 4. So number 4, we have this. We have 2x minus 1 divided by x minus 4 equal 7 divided by x minus 4. Okay. Now you see you have a rational equation, right? But notice this time you have variables in the denominator. First thing you got to do is factor the denominators. But notice x minus 4, I cannot factor any further. Okay, so once you factor the denominators, and you're going to see that next week is where you're going to see more of this next Monday or Tuesday, next Tuesday. So you got to factor the denominators, which you cannot here. But now you want to find the restriction, just like we did this. You got to find the restriction because you remember, whenever you have a variable in the denominator, you got to find out what makes that denominator 0. See, there was no variable here, so that's always going to be a 3. So that's why we didn't look at this. This did not have a variable. This fraction right here did not have a variable, so I didn't worry about that because that's never going to be 0. But this can be 0. This denominator can be 0 when x is 0. 25 times 0 is 0. This denominator can be 0 when x is 0. 15 times 0 is 0. So that's why you see this. Over here, though, ask yourself, where is x minus 4 equal to 0? When is this denominator 0? Well, this denominator is 0 when x equals 4. Solving for x. Add 4 to both sides, right? So that's your restriction. So the restriction is that x cannot equal 4. Because if x was 4, 4 minus 4 is 0. That's undefined. You get some number divided by 0. Same thing here. When x is 4, 4 minus 4 is 0. You get 7 divided by 0, which is undefined. So whenever you're solving a rational equation and you have variables in the denominator, you have to first of all factor and then find your restrictions. You're going to see more of this Tuesday of next week. Okay, now once you find, now we got to find the LCD. So your LCD is going to be just x minus 4. X minus 4. Now once you find your least common denominator, you're going to multiply both sides by the least common denominator. But I want to remind you, see that's only one fraction, so I don't need to put that in parentheses. So I'm going to say, I'm going to rewrite this over, 2x minus 1 divided by x minus 4 equal, and then 7 divided by x minus 4. So I just rewrote the original problem over. So now I'm going to multiply both sides by the LCD, x minus 4, x minus 4. And remember, the whole point of multiplying by the LCD is to get these denominators to be 1s, and they now are. The x minus 4's divide out, the x minus 4's divide out. And now notice what you have. 1 times 2x minus 1 is 2x minus 1 equal 1 times 7 is 7. So notice I went from a rational equation to a linear equation. I went from a rational equation with variables in the denominator to a linear equation where the denominators are all 1s. 1s, you see all these are all 1s. 1s, 1s. So let's go ahead and solve this linear equation. I add 1 to both sides. So I get 2x equal 8. Divide both sides by 2. I get x to be 4. So this is my proposed solution. Notice I use the word proposed solution. Because it's called a proposed solution because that is a solution to this. That is true. Watch. 2 times 4 is 8. 8 minus 1 is 7. But is it a solution to the original equation? And the answer is no. This is not a solution to the original because notice if I substitute x equal 4 into the original, if I go ahead and check it, I want to show you. If I go ahead and check this, here's the original. 2x minus 1 divided by x minus 4 equals 7 divided by x minus 4. If I substitute 4 where we see the variable x, I want to show you something. 2 times 4 minus 1 divided by 4 minus 4 equal 7 divided by 4 minus 4. Notice the denominators. 4 minus 4 is 0, right? You cannot divide by 0. So all you have to do is this. Whenever you have variables in your denominator, you find your restriction. You do all this work. Here's your proposed solution. Okay? If that proposed solution is your restriction, and that's the only proposed solution, then you're going to say the answer, no solution. No solution. So this equation has no solution because my proposed solution was a restriction. So as you go through these problems this week and a couple of days next week, you're going to see that your proposed solution is not a solution to the original because it's a restriction. Now I want to say this. Some textbooks, when you're at this level, will call this right here an extraneous solution. Extraneous, E-X-T-R-A-N-E-O-U-S, solution. You're going to see this again next semester when you solve radical equations, where you're going to have extraneous solutions. But extraneous solution, just think of a false solution. It's the idea of that false solution. A false solution. So x equal 4 is an extraneous solution because you think it's a solution to the original, but it's not. It's a solution to this right here, but this equation is not the same as this one. This has variables in the denominator. This does not have any variables. So that's a false solution. So don't say your solution is extraneous. You just say no solution here because that was the only proposed solution. That was the only proposed solution, and that proposed solution was our restriction. So there's nothing else, no other proposed solutions to look at. So you say no solution. All right. So that is a very quick review of the topic here on solving rational equations. So we only did 4 problems in about 30 minutes. Look at the other lessons that are there to get you through the rest of this. I'm going to go ahead and end this part.